Alright, so we want to try this problem first of all using the quotient rule. So you should be able to pause this and you should be able to do that right now. So hopefully you just got back from pausing it and we're using the quotient rule. K prime, and that's going to be low d high minus high d low over low squared. Alright, so that's going to be 6x, and if we distribute that, that's going to be minus 6x and then minus 15. And that's all going to be over 9x squared. So these are going to cancel. We're going to have negative 15 over 9x squared, which we can divide those both by 3. So that's going to be negative 5 over 3x squared. So then it says, can we avoid using the quotient rule? Now I believe I've talked about this absolutely once, maybe twice or 3 times. When you have a single term in the denominator here, we're going to split that up using the reverse common denominator, or however you want to think about that. So most of you probably could do this step in your head a little bit here, but I'm just, for the sake of the notes, writing it out in detail. So that's what's happening. And then if we rewrite both of these, this is going to be 2/3, and this is going to be 5/3 x to the negative first power. So I would assume that most of us could skip this step right here and just reduce that in our head and rearrange that. So now if we take the derivative of this, the derivative of this is 0. The derivative here, if we bring down negative 1, multiply it by that, and then subtract 1 from the exponent. Students often make a mistake there when they subtract 1 from that and think it's 0 or something. Negative 1 minus 1 is negative 2. And then that is the same as that. Okay, so hopefully you realize that is preferable, either way, is better. That's better. All right. Use an identity and then the product or quotient rule to find the derivative of secant. So don't look down here. So secant, an identity for that would be 1 over cosine. Now, one of the things I think about when I think of those is secant and cosine, it's the opposite. Like, it would be nice if secant was sine, because they both start with S, but it's not. It's the opposite. So secant goes with cosine and cosecant goes with sine. So there's kind of a switch there with the letters, and that's kind of how I remember it. All right, so now if we use the quotient rule on this, we have low d high, but the numerator is a constant. The derivative of constant is 0, so that would be times 0, minus high d low, the derivative of cosine. You should have all of these memorized by the end of this lesson, all the trig functions. So this is minus sine x over low squared. So that would be cosine squared. So this is going to be 0, cosine times, and then here we're going to have sine over cosine. So if you think about sine over cosine squared, well, that's a little awkward. So maybe sine and cosine, because having a sine and a cosine squared, that doesn't go together. Sine squared and cosine squared, those go together well, but sine and cosine squared, that's a little awkward. So separating that out, now hopefully we have an idea there. If we separate this and we do 1 times sine, we have 1 over cosine, and we have sine over cosine. So 1 over cosine is secant, and sine over cosine is tangent. So the derivative of secant is secant tangent. And we want to start memorizing that. So the other day, we did the derivative of tangent. So the derivative of tangent is Now hopefully you can fill this out. Pause and fill it out. So tangent is secant squared x. So you should start memorizing that right now. Tangent is secant squared x. Tangent secant squared x. Secant, we just did, is secant tangent. Secant x, tangent x. Don't forget that angle in there. Okay? Now, when we move down to these two, it's pretty easy because to me it has parallel structure. Like in English, if you say he was walking and talking and playing with a yo-yo, like they all have to have ing on the end to keep parallel structure. So there's sort of a parallel structure here. So first of all, when you do, all of the co-functions have negative derivatives. So that's easy to remember. All of the this says both, but actually cosine also. The derivative cosine is negative sine. So all of the trig functions that start with the letter C have negative derivatives. And then it's a parallel structure here. So tangent is secant squared. Cotangent is cosecant squared. Secant is secant x tangent x. Cosecant is negative, and then it's cosecant x cotangent x. So they kind of, so do you have to memorize 6 things? Sort of, but these two are very similar as far as what's happening there. These are very similar to what's happening here. So all the co-functions are negative. So knowing those other little details, I think, makes it easier. Okay, so let's go down here. We have the quotient rule. Find the derivative of this. So low d high. So the derivative of secant is secant tangent. Low d high minus high d low. Now the derivative of this is going to be, 0, and the derivative of tangent is secant squared. Now hopefully you're not looking up there for all of these. You're kind of, can't get that off. Oh yeah, I can. All right. Not all the way, but try not to look at those up there. Cover them up, something. Over low squared. Remember, if we were going to square that, we would have to FOIL, so don't bother. That's not, you don't just square those separately. You don't just distribute the square. You'd have to FOIL. Anyway, so now if we look up here, we can factor out a secant. So secant x. So if we factor out that secant x, and then, so that came out. Now we distribute this tangent in here. That's going to be tangent x plus tangent squared x minus secant squared x. All right? And that's all over 1 plus tangent x squared. Now, when you see trig functions squared, like tangent squared and secant squared and sine squared and cosine squared and cosecant squared, you should think of the Pythagorean identity. So the Pythagorean identity is sine squared plus cosine squared equals 1. And you don't have to have every single identity memorized, but you do need to have some basic ones because then you can adapt those to find the other ones. So I can see that I have tangent here, tangent squared. So I want a tangent squared from here. So to get tangent squared out of here, I'm going to divide by cosine squared. So sine squared divided by cosine squared is tangent squared. That's 1. And this is secant, because it starts with C, so the other one's a S. So secant. So tangent minus secant, tangent squared x minus secant squared x equals negative 1. So I can switch that to negative 1. So now we have secant x and we have tangent x minus 1 And that's about all we can do there. Okay. If you did this all in pencil, you might want to put a little barrier in between there just to show that there's two things there. Same thing down here. If you're not using different colors, you might want to draw a dividing line in there. All right. So let's see. I'm going to use a different color. So low D high minus high D low all over low squared. Okay? So now if we multiply that out, that's going to be cosine squared. And if we distribute this, now I'm going to rearrange this a little bit. So when I multiply here, I would get a negative times a negative is a positive. I would get positive sine x, and then I would get positive sine squared x. So I'm going to put the sine squared first, and then the sine. Okay. And this is equal to 1. So that's going to be 1 plus the sine of x. Now, what you should think about here is cosine squared. So one of our strategies for simplifying trig functions is to get everything in the same type. So that's a cosine, this is a sine. So could we switch cosine to sine? Well, actually, look over here. Cosine is equal to 1 minus sine squared. So I could substitute 1 minus sine squared for this. 1 minus sine squared x to replace this. And if you look at that, that's the difference of two squares. So I could factor that as 1 plus sine x, 1 minus sine x. Okay, you say, well, why did you think to do that? Because I knew I could switch. I knew that cosine squared, I told you anytime you have a trig function squared, you should be thinking of these options. So I was already thinking about this because of the cosine squared, and then I realized I could get this all in terms of sine, and then that's the difference of two squares. So that's going to cancel out. That's going to be 1. And our final answer will be 1 over 1 minus the sine of x. One more time, 1 over 1 minus sine x for our final answer on that one. All right, so this means something in purple here. So you should pause this immediately and you should do something right now. Pause. Now. No, seriously. Pause the video and do what you're supposed to do. Alright, so you're back and you did what you're supposed to do. So when you see the equation of a tangent line, we have a point here. We should immediately go into point slope form. So that's going to be y minus y equals x minus pi over 4. So I know that my answer is going to look like that. All I have to do is find the slope. I'm going to do both of these other ones as well. So if you haven't done them yet, you should pause now and you should do B and C. I just showed you what you should be doing. So, and you should be back by now. So that's y plus pi equals and x minus pi. Okay, so that's also, need to calculate a slope there. And finally down here, this is going to be y, pause that if you haven't, y minus 1 equals x minus pi over 3. So that's automatic. Partial credit, you should be getting stuff in there. Okay? Now, find the equation of the tangent line at that point, so we need the derivative. So we need y prime. So the derivative of tangent is secant squared. So we have secant squared x. So we need to evaluate that at pi over 4. So we may want to rewrite that a little bit. That's going to be secant of pi over 4 squared. Now, pi over 4, you should be able to do off of a 45-degree angle. Pi over 4 is 45 degrees, so that's root 2 over 2. So, but secant is 1 over cosine. So that's going to be 1 over root 2 over 2 squared. So if this is a complex fraction, if we multiply that by 2 over 2, that's going to give us 2 over root 2 squared. So if we square that, that's going to be 4 over 2, which is 2. Okay? That's it for that. We could draw a triangle if we needed to. If you need help with that, let me know sometime. Come in and we'll go over some other options. All right. So here we have x times the cosine of x. So that's a product rule. So we take the derivative of the first thing. That's going to be 1. So that's going to be cosine x. 1 times cosine x. Derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. So that's negative sine x. So I can plug in pi. So that's going to be the cosine of pi minus pi times the sine of pi. Alright, so cosine of pi is negative 1 minus pi times sine of pi is 0. So that's gone. So the slope is negative 1, or I could just put a negative there. That'll do it for that. Okay, now let's see here. So we need the derivative. Derivatives are for slopes. We need the derivative of this to calculate the slope. So the derivative of secant is secant tangent. Derivative of this is negative sine. So that's going to be a negative times a negative. That's going to be positive. So 2 sine x. So this is going to be the secant of pi over 3 tangent pi over 3 plus 2 times the sine of pi over 3. Okay, so this is going to get a little bit awkward perhaps. We can think about some options here. So pi over 3 is 60 degrees. So one way you could handle this is you could draw the triangle in the first quadrant. So the way we used to do that back in Irish geometry is we would put 1, root 3, 2. But you can also use this as 1 and then go backwards. The short leg would be 1/2 and the long leg would be root 3 over 2. Alright, for a 60-degree angle there. So cosine is adjacent over hypotenuse, cosine. So that would be 1/2, but secant is the reciprocal of that. Secant is the reciprocal of cosine. So it would be 1 over the cosine of pi over 3. So the cosine of pi over 3, cosine is the x coordinate if this was on the unit circle and this was a coordinate up here. So it's 1 over 1/2. So that's a complex fraction. If you multiply by 2, you're going to get 2. So that equals 2. Now, the tangent, you could use a unit circle here or a triangle, and the tangent of 60 degrees, tangent TOA, opposite over adjacent, so it'd be this over this. If we multiply them both by 2, we get root 3. And the sine of pi over 3, that's going to be opposite over hypotenuse. That's going to be root 3 over 2. Okay. So we have 2 root 3 plus 1 root 3, so that's 3 root 3. So that would be our slope here, 3 root 3. I can do that with a unit circle. I can make a table. You can make a table for tangent. There's somewhat of a pattern. So you could put the angle here. So 0, pi over 6, pi over 4, pi over 3, pi over 2. So the tangent of 0 is 0. The tangent of this is root 3 over 3. This is 1. Tangent of 45, opposite over adjacent, right isosceles triangle. This is just root 3, and this is undefined. And then it continues, you keep going through there. This will be negative root 3, and it goes back down the other way. So there's lots of different ways you can figure out stuff in Trig. You can use a unit circle, you can use triangles, you can use tables. All right. So moving on from trig derivatives, we're going to talk about higher order derivatives. That just means you take the derivative again. Okay, so it's not really that bad of a concept. So here, if we take the derivative of this, you all should be able to pause and you should be able to take the video of that. So do that. So y prime or f prime of x or dy dx. Now, some students get confused by this notation here, so you want to make sure that you're aware of that. That doesn't mean x squared. It just means the second derivative of y with respect to the second derivative of x. So that's one symbol, all of that together. Okay? So now, if you think about it, with y double prime, you're just going to take the derivative again, or you're going to take the derivative of this. So hopefully you can kind of think about what that would be. Maybe paused it and got that. And now you just keep going. You keep taking derivatives, and you go step by step. So that's going to be 48x, and you take the derivative again, that's going to be 48. Now, let's think about the nth derivative, the derivative taken n times. So let's think about x to the n. If we were to take the derivative one more time than the exponent, so let's think about that here. So notice after y triple prime, then they just put a 4 up there. So let's think about y to the fifth derivative of y. Okay? Well, if I take the derivative of that, I'm going to end up with 0. So if you think about it, if you take any derivative one more time than the degree, so taking it the degree times, you're going to end up with a constant. But if you take it one more than that, it's automatically going to be 0. Because you're going to run out of the variables, and then that last step here, you're going to get a constant when you do the same as the degree, the same number of derivatives as the degree. And then if you go one more time, it's going to be 0. Okay, so let's try this one out. Second derivative of this. So the first derivative, we have to use the product rule. So the derivative of this is 1. Derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. So it's just patterns. It's just a lot of memorizing the details of how to do things. And a lot of calculus is not too bad. Some of it's hard, but most of it is just memorizing what to do and doing it. So that leaves us with cosine x minus x sine x. Now we need to take the second derivative. So we're going to take the derivative of cosine, which is negative sine, and now we need to take the derivative of this. Now, I think I'm going to just move that negative out of the way so I don't get confused. So I'm going to keep the negative outside, and I'm going to take the derivative of this. So I have to use the product rule again. So the derivative of x is 1 times sine of x plus x times the derivative of sine, which is cosine x. Okay? So now if I distribute that negative, I'll have negative sine minus sine, that's negative 2 sine x. Don't forget the angle in there. And then minus x cosine x. And there's not really anything we can do with that, no simplification. So this is probably going to be harder than anything on the AP exam as far as the algebra, but I like to make sure that if I give you stuff that's pretty hard, then there's nothing they can throw at you that's going to throw you off. So do your best on this, at least copy down what I'm copying down. If you lose track of what's going on, it's not the end of the world. But you know, you should be able to give it a decent shot. So one of the things we're going to do here is a little rewrite on this. So that's going to be x plus 1 to the 1/2 power. So we have a quotient here. We're going to use the quotient rule. So low d high minus high d low. Now when we do d low, that's going to be 1/2 x plus 1 to the negative 1/2 all over x plus 1. When we square that, it would just be the first power. I don't normally write first power on stuff, but I am this time. Now, as you're looking at that, you should think about what that means. This is a complex fraction because if I rewrote this, I would have to write this underneath this. Not down here, just underneath this part, which would give me a fraction right there. So I don't like that. So I want to get rid of that. So if I multiply this by x plus 1 to the positive 1/2, that would cancel this out. When you multiply two things of the same base, you add the exponents. 1/2 plus negative 1/2 would be 0, and that to the 0 power would be 1. So if I multiply that across, here, that's just going to become 4 times x plus 1. Here, those cancel. Half of 4 is 2, so that's just going to be minus 2x. And down here, if I multiply these two things together, I add the exponents, so that's going to be 3/2. And we're almost done there. We're going to multiply that out, so that's going to be 4x plus 4. So 4x minus 2x is 2x plus 4, and x plus 1 to the 3/2. That's y prime. You could factor 2 out of here, get 2 times x plus 2. That's probably not really super helpful right now. So, okay. Now, this could get a little bit tricky here. Maybe we should use the well, let's see. So we need to find y double prime. So now we need to take the derivative of this. So that's going to be low, which will be x plus 1 to the 3/2. D high. Well, the derivative of 4 is 0, so it's just going to be 2. Minus high d low. So for high, I think I'm going to use the factored version here. So high d low. So d low is going to be 3/2 x plus 1, and you have to subtract 1 from that, so that's going to be 1/2. 3/2 minus 1 is 1/2. And that's going to be over this squared, and this squared is x plus 1 cubed. If you raise that to the second power, power to a power, you multiply. All right? Now, there's a couple things we can do in there. We see this 2 here. We can cancel that 2 out. Now, if you look at the numerator, there's an x to the 1/2 here. If we factor that out, that's going to clean this up nicely. Stuff in calculus simplifies and reduces a lot. So if we factor out an x plus 1 to the 1/2, and we think about what does that leave us with? So if we factor out, so again, if you get lost in here, it's not that big of a deal. Just copy down what I'm writing. So if we factor out x plus 1 to the 1/2 here, we'll have x plus 1 left, because we add the exponents together to get that. But I would have that x plus 1 times 2. So that would be 2x plus 2. Okay, and we factored this out, but we still have a 3. So I'm going to leave that, I guess, minus 3x plus 2. I guess I could have left the other one as well just so you could see it maybe a little bit better. And that's going to be x plus 1. Oops. That's supposed to be the exponent. X plus 1 cubed. That's what we wanted there. Okay. So now we're going to do a couple things here. So here, these are the same. So I could reduce this 1/2 into there. So that's 6/2. That's 1/2. So that 1/2 will cancel out 1 out of the 6/2, which will leave us 5/2. So that's going to be x plus 1 to the 5/2. Up here, if we distribute that, that's going to be negative 2x minus 3x is negative x. And then here, that's negative 6. 2 minus 6 is negative 4. Okay. That is a lot more algebra than they're probably going to put because the AP Calc test is timed, it's limited, so they're not going to have you do all that algebra. But the basic concepts, why are we doing it? Because the basic concepts are you will have to take a second derivative or something like that. It just won't be as much. Okay, moving on. This is something I asked a few times that they could ask. So they're asking for the 27th derivative. So what's interesting about this is it kind of matches the powers of I. If you remember that from Algebra 2, you probably did I to the 15th power and stuff like that. So what we're looking for is a pattern here. So if we take the first derivative of cosine, we get negative sine. If we take the second derivative, if we take the derivative of sine, we get cosine, and the negative stays there. And if we take the third derivative, so now if we take the derivative of cosine, we get negative sine, but we have a negative, so it would be a negative negative, so it would be positive sine. Okay? Now, if you think about it, let's just do one more. Or maybe I'll put it over here. So if I do the fourth derivative of x, that would be the derivative of sine, which is cosine. And if you want to keep going, you'll notice the fifth derivative, sixth derivative, the seventh derivative, etc. All right? So it works the same way the powers of I do. If we divide how many times we're going to do this by 4, that will give us some important information. So that's going to be 6 times. That really doesn't matter. We don't care about the 6. What we care about is the remainder. So the remainder tells us which derivative we have. Now, if the remainder is 0, so you think about this one. So that was the fourth derivative. If we divide it by 4, we get 1. 4, 0. We get remainder 0. So that would be like the 0 derivative. We haven't taken a derivative yet. So if we get remainder 0, that's like this. Remainder 3 is going to be like the third derivative. So whatever remainder you get, that's which derivative you're looking at. So we are looking at the third derivative. Like I said, this doesn't really matter. We're looking at the third derivative. So our answer, the 27th derivative of x, is equal to the sine of x. Pretty simple. So whatever they give you here, you're going to have to find however many you need to find the remainder. So that's how you'd want to show your work. All right, so we talked about the position function already, and so there's the position function. If we take the derivative of position, we get velocity. So we know that. If we take the derivative of velocity, we get acceleration. So if we take the derivative of velocity, that's like taking the second derivative of position. So you need to know how these three things relate to each other. The second derivative of the position equals the acceleration. You need to be able to move back and forth between those. All right, speed is the absolute value of velocity. Velocity can be negative, depending on the direction. Okay? This is very important. You need to memorize this. The speed increases if the velocity and the acceleration have the same sign. And the speed decreases when they have opposite signs. Okay? So I can demonstrate that with this pen maybe, or a highlighter. So if I throw this in the air, I throw it in the air, and as I throw it up in the air, it has a positive velocity, but it has a negative acceleration. Gravity is negative. Gravity is pulling us down this way. So since the velocity is positive and the acceleration is negative, it slows down. The pen slows down. And then it stops, and then it falls back to the ground. Now it has, if it's falling, it has a negative velocity. And acceleration is negative. So a negative velocity and a negative acceleration is going to speed the pen up. So as it falls, it speeds up. Okay? So when the velocity and acceleration have the same sign, in case of the pen, both negative, the object speeds up. When they have opposite signs, like when I throw an object up in the air, it has a positive velocity but a negative acceleration, it slows down. So that's really important. Okay, so let's look at this. Find the velocity and acceleration when time equals 4 seconds. Indicate units of measure. So on the AP exam, if they want you to put units, it'll say indicate units of measure. If it says indicate units of measure and you don't, then you will not get the points. Okay. So the velocity is the derivative of position. So the velocity equals the derivative of position. So that's going to be 3t squared minus, and again, you should be able to pause that and do that yourself, but okay, so that's the velocity. And then over here, I'm going to do the acceleration. So you could do the acceleration, and we could say that that's the derivative of velocity, or you don't have to put both of these, but so that's going to be the derivative of this, which would be 6t minus 12. Okay, so then the question says, find the velocity when it's 4 seconds. So v of 4, I'm going to plug 4 in there. So 3 times 4 squared minus 12 times 4 plus 9. So that's going to be 48 minus 48 plus 9. So that's going to be 9. And it said meters, so that's going to be meters per second. Okay. And over here, that's going to be the acceleration at 4. So that's going to be 6 times 4 minus 12. So it's going to be 24 minus 12. It's going to be 12 meters per second squared. Acceleration is meters per second squared. Okay, so now we have, is the speed increasing or decreasing at t equals 4 seconds? So what you need to do is, if you look at this highlighted stuff, is you need to compare the acceleration, the velocity and acceleration at 4 seconds. So we would say it's increasing because, very important, because v of 4 and a of 4 have the same sign. And in our work somewhere, we would want to have some evidence of that. All right? Now this video is getting pretty long, so I'm going to go ahead and cut it off here, and I'm going to do this problem later, and then I'll attach it as a second video because I don't want to jeopardize losing what I already have here. So we'll continue this on